All right, let's dive in. We're going to spend the next few minutes uncovering some of the hidden weaknesses in the technology you and I use every single day. I'm talking everything from the apps on your phone to the huge cloud networks that basically run our world. Vulnerabilities are everywhere. So let's start peeling back the layers. So you think your phone, your laptop, all your stuff is locked down tight? Well, let's really find out. We're about to peel back the layers of our digital world, kind of like an onion. We'll start with the stuff you can see and then dig deeper and deeper into the systems you can't. Okay, so first things first, what are we even talking about when we say vulnerability? Well, in the simplest terms, it's a weakness. It's a crack in the foundation, a flaw in the design, or sometimes just a simple mistake that an attacker can take advantage of. The best way to think of it, it's like a broken lock on a digital door, just sitting there, waiting for someone to come along and jiggle the handle. So here's our game plan. We're going to start with the code and the apps you use every day. Then we'll dig down into the hardware itself. After that, we'll zoom way out to the cloud and the whole supply chain, then bring it right back to the device in your hand, and we'll finish up with the most unpredictable threat of them all, the 0 day. All right, first stop, the code. The applications and websites you use are basically the front lines of your digital life, and because of that, they are an absolute prime target for attackers who are looking for an easy way in. Let's kick things off with a real classic, the buffer overflow. Okay, imagine this. You've got a pint glass, but you're trying to pour a whole gallon of water into it. What happens? It's going to spill everywhere, right? Well, in the world of software, that spill can actually overwrite critical parts of the program's memory, which can literally let an attacker hijack the program and run their own malicious code. So how do you fight something like that? Well, luckily, developers have some pretty clever tricks. Besides carefully checking their code and validating inputs, they use this technique called a stack canary. It's basically a small, random value that they place in memory, and it acts like a digital tripwire. If an overflow tries to overwrite it, the system knows immediately that something's wrong and can shut the whole attack down before any real damage is done. Pretty smart, right? Then you've got something called SQL injection. And honestly, this one's kind of like a magic trick, a really malicious one. An attacker doesn't smash down the door. Instead, they just ask a question in a very, very tricky way. They'll type some malicious code into a search bar or a login form, and it confuses the website's database into handing over information it absolutely shouldn't. We're talking usernames, passwords, you name it. And then there's cross-site scripting, or XSS. Now this one is nasty because it weaponizes the very trust you have in a website. An attacker manages to sneak a piece of malicious code onto a site that you know and use. Then, when your browser loads that page, it just runs the script because, hey, it trusts the website. And that script can then steal your session cookies, your login info, all sorts of sensitive data. Okay, you ready? We're peeling back another layer of that onion. We're going deeper now, moving past the apps you see, down to the machine itself, the operating system, the physical hardware, and even the virtual worlds that run on top of it. Down at this level, a couple of big risks really stand out. One is having the firmware compromised. That's the super low-level software that makes your hardware actually work. But, an even more common issue is just old age. When a device hits its end of life, or EOL, the manufacturer just stops sending security updates. That's like the company walking away, leaving the front door of your house unlocked. Forever. All right, now this next one, this is a true nightmare scenario in the IT world. It's called a VM escape. See, a virtual machine is supposed to be like a perfectly secure, isolated digital jail cell. A VM escape is when an attacker finds a way to break out of that cell and gets access to the warden's office, the physical host machine that runs everything. From there, they could potentially access every single other cell in the prison. All right, let's pull the camera way, way back now. We're zooming out to the biggest layer yet, the massive global cloud infrastructure and the incredibly complex supply chain that builds all of our technology. So, when we say the cloud, what do we even mean? Because it's not just some fluffy thing in the sky, right? It's really a set of services. SaaS, or software as a service, is the finished product you use, like Gmail. IaaS, infrastructure as a service, is like renting the raw building blocks, servers, and storage. And PaaS, platform as a service, gives developers the tools they need to build their own apps. And guess what? Each one has its own unique security challenges. And all this stuff has to live somewhere, right? That's where you get the split between a public cloud, think massive providers like Amazon Web Services or Google Cloud, and a private cloud, which is custom built for just one organization. The public option is cheap and easy to scale up,
while the private one offers way more control and security, but it costs a lot more.
And this is where it gets a little scary. It leads to this chilling realization. Your security is only as strong as your weakest link. And that weak link might be a company you've never even heard of. A single tiny vulnerability in a piece of third-party software you use, or a compromised chip from a hardware supplier, can bring your entire defense crashing down. Okay, after all that big picture stuff, let's bring it all the way back home. Right back to the device in your pocket and, well, to us. The simple mistakes that any of us can make. It's kind of wild. We spend all this time thinking about super sophisticated hackers, but honestly, one of the biggest threats out there is just simple human error. Misconfiguration, which is really just a fancy way of saying setting something up wrong, is a huge source of security breaches. We're talking about things as simple as leaving the default password on a device or accidentally leaving a sensitive database totally open to the internet. And speaking of being our own worst enemy, let's talk about our phones. Sideloading an app from some random website might seem handy, but you're totally bypassing all the security checks that the official App Store has in place. And jailbreaking your phone to get more customization? Well, you're also stripping away all the security layers the manufacturer put there to protect you, leaving the door wide open. Okay, we've reached the very center of the onion, the final layer, and this is the ultimate wildcard in cybersecurity. It's the threat that no one, and I mean no one, sees coming. So what in the world is a zero-day? The name says it all, really. It's a flaw that attackers find and start using before the software developer even knows the problem exists. That means the good guys have had, you guessed it, 0 days to create a fix. There's no patch, no update, no warning, and that is what makes them so incredibly powerful and dangerous. So, how on earth do you defend against something you don't even know exists? Well, you can't block a specific attack you've never seen before. Instead, you have to build a fortress. That means always keeping your systems updated, using multiple layers of defense like firewalls, being super strict about which applications are even allowed to run, and maybe most importantly, constantly monitoring everything for any weird behavior that could be the first sign of an attack. Whew. Okay, let's just do a quick recap of this whole journey. We've gone from a single line of bad code that causes a buffer overflow all the way out to a hidden flaw in a global supply chain. We've seen how a simple mistake in setup can be just as bad as a super complex VM escape. Every single layer of our digital world has its own unique weak spots. So what's the big takeaway here? It's that our digital world is this incredibly complex, interconnected system. A vulnerability isn't just one thing. It's a potential weakness that can pop up at every single level, from the code in the app you're using right now to the massive global network that it's running on. And that really leaves us with one last big question. If a brand new, completely unknown threat can appear at any time out of nowhere, what's our single best defense? It isn't just one piece of software or one firewall. It's vigilance, it's awareness, and it's never, ever stopping the drive to understand and adapt to what's coming next.